We'll cover this term polarization, and then we'll be solving some very basic electricity problem. Okay, that we can do it. So basically, there are two type of waves. Okay, one is a transverse wave, one is longitudinal wave. Longitudinal wave is a wave when particle vibration is same in the direction of motion. Okay, and transverse wave, that wave propagation is perpendicular to the particles vibration. If we see electromagnetic wave, EM wave will have two components, or basically two vector. One vector we called as electric field vector, and the second component we called as the magnetic field vector. Okay, this electric field vector and magnetic field vector both are always perpendicular to each other. Okay, so if you see this electric field vector is in y-axis, so magnetic field vector will be along x-axis. Okay, so that is how our EM waves travel. Okay, so always E vector and B vector will be 90° to each other. Now, what exactly a polarization of wave is? So polarization can take place only in case of a transverse wave. So if this wave in this picture, if you can see, let's say this wave is coming like this, and you have a vertical slit over here. Are you able to see this slit? Okay.
Yeah.
So this wave will continuously moving like that, and it will not change any type of its orientation. So wave is coming like this, and it will continuously moving like this. But if you keep a horizontal slit over here, then this wave, which is moving like that, will not be able to keep be in the same orientation, and it will be like this. Okay. So this particular thing we called as the polarization. So polarization is nothing but restricting to of oscillation in any plane or in any direction. Okay, that we can do by using polaroids and all. Okay. Why we can see in case of transverse wave only? I believe that is clear to you because oscillation is perpendicular to the propagation of wave. But if in a longitudinal wave, both are in the same direction, so they will come out from the slit directly, whether it is horizontal or vertical. Okay. Is this much clear to you?
Yes.
Okay. So two things. In case of EM waves, we have electric field vector perpendicular to the magnetic field vector. And in case of transverse wave, we can see polarization. Okay. Now, what exactly the polarization is? So if you see any wave component or any electromagnetic wave has lot of direction of propagation. Okay. And if we want to have a unique direction of propagation, then we use this polarizer. Okay. Or we want to polarization. Okay. So if you want to remove the all horizontal component, so we will have this type of wave. So this is an unpolarized wave, and this we can say a vertically polarized wave. If we want to see a horizontal part of the wave, so that we can say a horizontally polarized wave. What exactly a unpolarized wave? Transverse wave can oscillate in any plane perpendicular direction of the motion, and that is basically the unpolarized wave. Basically, energy is getting transferred in all direction. If you want energy to be transferred in one unified direction, we need polarization. Okay. Now, one last thing, how can we do that? It's a very simple process. Let's say you have a unpolarized wave, which has a particle vibrating in all random direction. So first of all, what will you do? You will provide a vertical slit. So after vertical slit provision, you can simply see in this diagram, you will have only vertical waves coming out from this. Okay. And then you can keep a horizontal slit over here. So this wave, which is moving in all direction, will finally come out like this. Okay. So what it is, restricting vibration of light electric field in a particular direction of plane, which is perpendicular to the direction of motion. That we call as the polarization of wave. Let's say we have a light source. Light source will produce a unpolarized light. If you want all light to be moved in a vertical direction, so you will keep that Polaroid in front of that, and you will get the direction vertical to it. Okay, is that clear to you? So that simple
Yes.
concept, and this much only we have in our